Hello friends, in today's lesson we are going to discuss basic operations on linked list. So we will be creating a linked list and then we will look at how we can traverse this list and then we'll look how we can insert a node at the beginning and how we can insert a node at the end and how we can insert after a specific node. Let's say we want to insert after node 6, how we can insert that. Okay. In our previous class, we talked about linked list is a collection of nodes and every node will have data and a pointer to its next node. Okay. So for creating the list, we'll have to create the object. Let's now go back to Visual Studio and the first thing what we'll do is we'll create a linked list node which can hold the data and a pointer to the next node, what we have discussed in our last videos. So if you have not seen that, so I'll strongly encourage you to go back and check out our first video, Introduction to Linked List, so that we'll understand how we are gonna create this node. Okay, so I will open the project. So if you are following my lessons, so we'll be using the same solution. So in this solution, let's create a new folder. Let's give it a name as linked list. Now, inside this linked list, I'll go ahead and create a new class. This class is a linked list node. So I'll give it a name as, let's say, list node. And this list node, okay, so this list node will have a field which can hold the data. Along with that, it should have the next pointer, the pointer to the next node. So let's add that. So this will be basically list node and we will give it a name as, let's say, next. Okay, and let's create the constructor, and inside the constructor I'm gonna pass the data, and I'll simply say this dot data is equal to the data what we are passing. Okay, so now we created a single node. Okay, now our objective is to create this list, this linked list. So let's create this linked list. Let's go to program.cs and create our linked list. So I'll just go ahead to program.cs. I'll create, let's say, list node, and this list node present in this namespace. I'll just bring in that namespace, and this will be my head pointer equal to new list node. And what is the first value? The first value is 8. We will add 8 to the constructor. Okay, now our head pointer has been created. So this is our head pointer. Now to the head of next, we're gonna add 6. So I'll just say head dot next equal to new list node. It will be 6. Next. So if this will be my head, so node, this node will be head dot next. Head dot next is 6 dot next. So this next is 5. So this is what we are gonna do. Okay. Head dot next equal to, again, new list node. We will add 5 over here. Now Another element also we need to add. So head dot next dot next dot next equal to new list node. The last element in our list is 7. So let's add that. Okay. So now our list has been created. The next thing what we want to do is traverse through this linked list. So how we can traverse through the linked list given a head pointer is given to us. The pointer which is pointing to the first node of the linked list is given to us. How we can traverse. Okay. So we'll print first head.data. Head.data value is 8. Now what we'll do is we will update the head pointer reference is head.next. So what we are doing on the next step, we are doing head equal to head.next. Okay, now head should point to 6. Okay, then we will print head.data. Once we print, again we will update to head equal to head.next. So now our head should point to head.next. Head.next is 5. So we are going to print 5. Now again same thing will do head equal to head.next. Head.next is 7. So it's going to print 7. So this operation we will do as long as head.next is not equal to null. If it is the last element in the linked list, then the next value will always point to null. The moment we will find head.next is equal to null, we'll stop our execution. Equal to null, we will not execute again. Now we will able to traverse through all our linked lists. Okay, let's write the code for it. Let's create a class for list operations. So I will call this as, let's say, list operation.cs. Okay, let's create this as a static class and list operation. So what we'll do, let's create our method. So public static, let's say void display list, and what will be the input to our function? So it will be the head pointer and it needs to be a list node head pointer. So in case the head pointer is null, that means the list is empty, so we'll not print anything, we'll simply return. In other case, if head is not equal to null, what we are gonna do, we will keep on updating the head reference as long as head is not the last element. So in case head is the last element, so it should be null. So as long as head is not equal to null, what we want to do, we want to update head to its next element, head dot next. Okay, now before updating the reference, let's print the data. So I'll just simply do console dot write line head dot data. All right, so this should actually print our list. So now let's go back to the driver core and see if the implementation is correct or not. So let's say console dot, we will just display it right line. We'll say the linked list is, let's call our method. So our method is in list operation dot display list. Now inside the display list, we'll simply give our root node or the head node. So let's pass it out and let's run our application and let's see. Now you can see this data over here. The linked list is 8657. We were successfully able to display the elements in the linked list. The next operation, what we want to do is insert an element at a beginning. For inserting a node at the beginning, we need to create the node first. Let's say we'll create the node, and in this node, the data element will contain 2, and we have the next element. Now, if it is the first element, then the node dot next should point to the existing head. So this is our head pointer. So this the new node's next element should point to the existing head, and if it is the starting node, now this needs to be our new head. So this will become our new head. Okay, so what we did over here, we created a new node. We created new node, and to this new node's next element, next pointer, new node dot next, what we did, the existing head. Okay, now we need to update the reference of the head. Head needs to be now this node. So this will become head equal to new node. Whatever new node what we created, that will become that. That is it for adding a node at the beginning. Let's implement this. What we're gonna do, we'll say public static, and this time we are gonna give back the head node, list node, insert at beginning, insert at beginning, and let's pass list node head. This is my head pointer, and we need to also pass the data, the node value for which we are gonna add at the beginning. You also need to pass this data. Let's say we are adding node 2, we need to pass to what data we want to create or what value we want to create. So we'll receive this as int data. What is the first operation we did? We created a new node. Let's create that new node first. So I'll say list node, new node equal to new list node. So this constructor takes the data value. So we'll just pass the existing data values. Okay. Once the new node has been created, let's check if our list is empty or not. So let's say if head is equal to null, then that means our list is empty. Then we'll simply do head equal to new node. In other case, if the list is not empty, what we want to do? We want to assign the new node's next pointer to the existing head and then update the head pointer value. Head should point to this value. So let's do that. So new node dot next equal to the existing head. Then we need to update the head pointer to, because now this node has been added at the beginning. So new node should be our head now. So I'll do head equal to new node. So now once this is done, so it's expecting a list node to be passed that needs to be our head node. So let's return our head, return head. Okay. So now let's execute this function and verify our implementation. Okay. So before calling the display list method, we are gonna call the list operation dot insert at beginning, and this time we want to insert 2 at the beginning, and this method is gonna give us back the head pointer. So we are gonna receive the head pointer. Okay, and this insert at beginning expects a list node head and the data. So let's pass our head pointer. Okay, and now the result what we have got, so this list should have already 2 added at the beginning. So let's display that list. Okay, so what we can do is, let's say list before. So I'll do over here. So in case of display list, so we'll do it as, I'll pass the head, and here we'll also update our head pointer, and we'll pass the same head to again. Now we can add the console statement linked list after insertion. Okay, let's run this and see. Okay, so you can see over here the linked list before what we had is 8657. Now we are adding 2 at the beginning. Now our new linked list is 28657. All right. So now let's look at the next operation. Now what we'll do is, let's say we will insert an element at the end of the list. So let's say our requirement is to add a node after 7. Okay. For inserting a node at the end, we need to create the node first. Let's say this is our node, and this node will add data as 10. And if it is the last node, then its next pointer should always point to null. Now in our existing list, this is our last node. Okay, this is already pointing to null, but we don't have any reference to it. We have a single reference head. Now we need to traverse through or update the head reference till we reaches over here. Now once head points to the last node, now last node dot next, we will do the new node what we are creating, and new nodes next is already pointing to null. That's all what we need. Let's do that. So what we did, we first created a new node, then we updated our head node reference to point to last node. Okay, so once it pointed to the last node, then head, then last node next pointer, we will assign it to new node. That is all operation we did for adding a node at the end of the linked list. Let's do that. Let's create our method. Let's say public static, and we will return back the list node. we will return back the head pointer. So we'll say insert at end and we'll receive the head pointer itself, list node, head, and then we'll pass the data to be added at the end of the linked list. We'll create the new node first, the node to be added. So I'll say, let's say list node is equal to, so let's call this as new node equal to, so new list node, and the data what we are receiving, we'll just pass it. In case the head is equal to null, that means the list is empty. So the new node will be our, so head becomes new node. So this will be the fast node in case the list is empty. So the element what we are adding, or the node what we are adding, that will become the fast node. So we are just assigning head equal to new node. In other case, if the list is not empty, what we want to do, we want to traverse till the last node. So before traversing, let's keep track of our head node. So what I'm gonna do is, so I will create a list node root, and I'll just say head, and I'll return my head node. I will return the root node. Okay, because we will be updating the reference of the head. So I just created a temporary variable and I'm returning it over here. So if the list is not empty, then what we're gonna do, as long as head dot next is not equal to null, so what we are gonna do, we'll simply do head equal to head dot next. So now after this statement, head should point to the last node. Okay. Now head is at the last node. So what we have to do, the last node dot next should point to the new node. Okay, so let's do that. Head dot next equal to new node. Okay, that's it. You can explicitly set new node dot next equal to null, because this will be our last node, but by default this next element, if we are not setting anything, this value will be by default null. So no need of writing this line. So I'll just remove this. All right, so this should add the element at the end. Let's run and verify. Let's run and verify. So I'll go to program.cs. Now we'll do the same thing. Okay, so what we are going to do is, we will update this text insertion at end, and we will call our method list operation dot insert at end, and this time we are inserting 10, and this also expects the head, so we'll pass the head pointer as well. Okay, now once we receive it, we'll update our head pointer. Now let's move this console statement just before displaying the list. Okay, let's run, and this 10 should be, I mean, the 10 should get added at the end. Let's run it. Okay, so you can see the linked list is after insertion at end. So it was 28657 when we started, and once we added 10 at the end, so this is our list 2865710. Okay, uh, now let's go to the next operation. Next operation is inserting an element after a specific node. Let's say we want to insert an element after the node 6. So after this node, we want to add another node which has data 9. Okay. We will create the new node first. So this is our new node, and this will have two fields. One is for data and one is for the next pointer. Okay. Now, if this node is getting inserted after this node, in that case, this node's pointer should point to this. Let's clean this. So now this node's next pointer should point to 9, and 9's next pointer should point to 5. This problem can be asked in two ways. Either you will have a reference to head node, or you will have a reference to the node after which the new node is getting added. Okay, so any of the cases, so we'll first create the new node. Okay, so once the new node is created, so in case the head pointer is given, so traverse to the given node, traverse till the node. So now our head should point to this node. So we'll update our head reference, and head should point to this node. So once we'll have our head, what we can do, so this is our new node. So new node dot next, let's just remove this. Okay, so our new node has been created and our list is in this condition. Now what we are doing, the new node dot next equal to head dot next. So currently head is pointing to 5, head dot next. So we are doing new node dot next equal to head dot next. Now once this operation finished, now we'll break this, and what we'll do, head dot next. Now this should point to the new node equal to new node. That's all we have to do. All right, so now let's implement this. Insert after specific node. So I'll go so public static, we are gonna return the head pointer list node, insert after a node. Okay, so in this case, let's say we will receive the head pointer. Okay, we'll receive the node data after which the node to be added. Let's say int node data, and then int new data. So this is the node which we are gonna add. So what we can do, let's first create our new node. So I'll create, let's say list node, new node equal to new list node, and I'll just pass the node data, the new node that is being added. In case the head is equal to null, that means the list is empty. And in that case, what we're gonna do is we'll simply say head equal to new node, new node. All right. So in other case, we need to update our head pointer reference till we reaches the node which contains this data, node data, right? So let's do that. So I'll do while as long as node is not equal to null, or basically head is not equal to null. What we want to do? Want to do head equal to head dot next. Okay. So now we are able to successfully able to traverse complete list, but we need to stop at when head dot data is equal to the data what we are expecting. If we got that data, so that means that's our head node. Okay, I'll simply break this. Now we got the reference to the node after which the new node is going to be added. Okay, the new node's next element will point to head dot next. Let's do that. New node dot next. New node dot next should point to head dot next. Now head dot next should point to the new node. So let's do that. So head dot next should point to the new node. Okay, so that's it. So now our head reference has been changed. So before we change that, let's grab that so that we can return our head node. List node, I'll say root equal to head, and let's return this root. Okay, now let's verify. Okay, so I'll just copy these two lines, and what we want to do, we want to insert after node 6, and after node 6 we want to insert, so insert after node 6 we want to insert 9. Okay, let's get the head node. All right, now let's display after this operation. Now we are passing head. Now this new node 9 should have added after node 6. Let's see. Okay, now you can see this was our list earlier 2, 8, 6, 5, 7, 10. So after 6, now a new node 9 has been added. These are the basic operations on linked list insertion. So for deletion also we can delete a node at the beginning, we can delete a node at the end, or we can delete a specific node. That is all on the basic insertion operations on linked list. Please subscribe to this channel to support us. Thanks for watching.